All right, everyone, so today we're going to be doing 9.5, which is going to be adding and subtracting rational expressions. So the rules for adding and subtracting rational algebraic expressions is the same as the rules for adding and subtracting numerical fractions with like or unlike denominators. First thing you have to do is you got to factor. Of course, you have to factor anything that needs factoring. Identify the restrictions early on, because sometimes restrictions can go away. They appear they go away, so we have to make sure we identify any as they come up. Reduce if possible, find the least common denominator, and multiply by the LCD and simplify. So I'm going to talk you through that process, and I just want to kind of bring this up because I've taught this 2 times today so far, and of course last year as well, but this is one of these kind of you have to trust the process situations. So I know that it's going to take time. First and second example might be a little cloudy, what's going on. But I promise you, as we get through more examples, you're going to start seeing what I'm saying. So just kind of, don't freak out if you don't understand the first example. It'll come, I promise. So let's talk about what the LCD is. Do you remember finding LCDs maybe in middle school, the least common denominator? So let's just talk a little bit about that. An LCD is basically the least common denominator we can have. So an LCD can never be smaller than your largest number in the denominator. Okay, it always will be bigger because it's the smallest number that both of these numbers divide into. So what's the smallest number that both 8 and 2 can divide into?
16.
Even smaller than that. Doesn't 8 go evenly into 8 as well?
Yes.
So the numerical portion of the LCD would be 8. So what's very common is if one of your numbers goes into the other, then the LCD is going to be the larger number. Does that make sense? Now, we're not done with the LCD. We have to do the variable portion. So as for the variable portion of the LCD, you look at any variables they have in common. As you can see, they both have an x in the denominator. So when that happens, you just take the higher power of those. Whatever one has the higher power. Now, for the y, the other one doesn't even have a y, so what's the highest power on the y? 2, right?
Oh, yeah.
So I take the one with the higher.
You said for the LCD that number cannot be smaller than the largest or larger than this. Can you repeat that? So
Yeah, so basically the smallest the LCD will ever be is the largest number in the denominator. Yeah, that's the smallest it could ever be. It will either be that or bigger. Okay. So does anyone have any questions about how we came up with this? And like I said, it will still start being more intuitive. I know it's kind of like a strange procedure.
For the LCD, is it the largest number like in the equation?
No, it's not. It doesn't actually have anything to do with the top or bottom. I mean the top itself. It only has to do with the bottom. So it's the smallest number that both of these numbers can divide into. Yes, what's up? Hang on, let me pause this because it's on. All right. Anyways, so we found our LCD. So that's going to be the new denominator of our big fraction, okay? So here's what we do next. We have to figure out what we have to multiply the top and bottom of each of these fractions by to get them to have that denominator, okay? So starting off, how can I get a 2 to become an 8? I'd multiply it by
4.
So I have to multiply the top and the bottom by 4. But I'm not done because I also have to get it to have a y squared in it. So I have to multiply the top and bottom of this fraction by y squared, okay? As for this fraction, what would I need to multiply this denominator by to get it to be this denominator? To go from this to this, what would I have to multiply by?
1 x squared.
X squared.
Oh, yeah,
X squared. So here's what you do from here. We don't have to worry about multiplying the denominator. We already know what the denominator is going to come out to be. We just worry about the numerators, okay? So what is this product going to become?
12 y cubed.
Y to the third. Everybody see why it's third? Okay. And then it's going to be minus, okay, because we have a minus sign right here. Now we multiply these together. What's that going to be? 5x squared z, right? Can't do anything else with that. So that's our final answer. Now we have to look at restrictions. So a restriction can exist in the beginning and come up later, but in all of these cases, what are the restrictions on x and y?
-2, -8. 0.
Yes. 0. So does everybody see why it's 0 and not the 2 and the 8? Only time it's going to be like 2 and a number is when it's like x plus or minus something. So if either of the x or y were 0 here, that would make the whole denominator 0. All right, you ready to try another one now that we kind of got started a little bit on it? Okay. So we'll kind of ease our way into it. Now we're going to deal with a situation where we have full factors, binomial factors, in our denominator. So first and foremost, I'm just going to rewrite all of this, and I'm just going to factor what I can factor. So you see how I can factor that denominator into two binomials? Does that make sense to everyone?
Oh, yeah, yeah.
Okay. Now, least common denominator in this case is just based on factors, okay? So what factor do these denominators have in common? Good. So that is always going to be included in the LCD, and you only need to include the factors they have in common once, okay? Now you look at anything in the denominator that one has that the other one doesn't, which would be what? X minus 3. That's our LCD, okay? So that's going to be my new denominator. So our goal is to have to multiply the numerators by whatever we would need to get that denominator to look like this one. So for the first fraction, how could I get that denominator to look like this one? Good. I'd have to multiply this fraction, top and bottom, by x minus 3, right? What would I have to do to the second fraction? Would I have to do anything to it to get it to have that denominator? No, it already does, okay? So here, maybe I should use a different highlighter. I'm just going to use the distributive property right here, okay? Good. 6x minus 18, right?
Yeah.
And then that's going to be plus the 2x that we have right here. Now I can simplify, and that's just going to give me 8x minus 18 all over this. Okay, any questions about that? What are my restrictions on this one?
3 and negative 3.
Good. Alright, so you're starting to get the hang of it now a little bit more? Okay. Let's go ahead and try number 3. First thing you want to do is factor as much as possible. I'm actually going to leave some room here so we can multiply by the numbers. So like I said, my expectation is just you know how to factor. So that's why I'm just going through it quickly. So does everybody understand how I got from point A to point B here? Okay. So now we look for what the denominators have in common, which is x minus 1. That will automatically always be part of your LCD. Now you look for what they don't have in common, which is good, and the x minus 2 has to be included as well. That's going to be the new denominator of my fraction. So, what would I have to multiply the top and bottom of this fraction by to get me to have this denominator? X minus 2. We don't really care about the denominator because we already know what it's going to be. Here, we simply can distribute this out. And then over here, we can distribute this out and add it to it. Plus 2x minus 16, right?
The two middle terms cancel out in comma.
Exactly. So what you're going to notice here in this case is those two middle terms happen to cancel out. Does everybody see that? So then I'm left with x squared minus 16 over this, which I could technically factor again if I wanted to, right? What would this factor into? X
Squared.
Do you remember this?
Oh, yeah, yeah.
So either one of these is a correct response. Okay, I would accept either one of these, but if it's multiple choice, you have to be aware that these are the same thing. All right? Any questions about that? How we got there? Okay. I forgot to do restrictions. So what are my restrictions here?
X plus 1 and X plus 2.
Forgot to put a line for that on that one. Does anyone need more time on that?
Yeah, I just want to.
Okay, go ahead. Take your time. Okay. Alright, so I'm going to zoom in here on number 4. Alright, so on this question, first thing I'm going to do, I'm just going to erase this here so I don't or just draw a line so I don't get it confused. So I'm just going to factor this completely. So does anyone have any questions about the factoring portion? Okay. So now I'm going to look for my least common denominator. I didn't put a line for this for some reason, but we're just going to write it here. What do the two denominators have in common? Good. We know that what they have in common will always be included in the LCD once. Now we look at what they do not have in common, which is what?
X and 2.
X and 2. So x times 2 is just 2x. So 2x times x minus 2 will be our LCD. So that's going to be the denominator that is the common denominator. Now I have to figure out what I have to multiply the numerators of these by. What am I going to have to multiply this fraction by to get that 2 that we need?
X. 2.
2.
Oh.
Sorry, I didn't mean to say it like as a trick question.
No, you good.
So that's just going to be 2 times x plus 2, which we can multiply out later. And then what are we going to multiply the second fraction by?
X.
X. So technically it's a minus, remember, don't forget. So it's negative x minus 2x. Now you can't cancel these things out because it's not multiplication. You see that subtraction sign or if there were an addition sign. So what we'd have to do to try to simplify this is we'd have to multiply it all back out. And this would simplify to give me this. And I'm not too concerned right now about you guys getting it into simplest form, okay? Like I will accept this answer right now. I just want to make sure you understand the procedure. And then eventually I would like you to get to the point where you're ready to simplify and move and manipulate the functions. But right now, as long as you understand this step right here and not getting it to this form, that's fine. What would my restrictions be here?
Positive 2 and 0.
Good. Alright, do we have any questions before we move on to the next thing we're going to address? Okay. Alright, so now we're going to talk a little bit about complex rational expressions. So a complex rational expression is basically a combination of what we learned about today and yesterday. So you basically solve each one of these separately, like we did today, and then you do keep, change, flip. So it's like you do what we did today, then you do what we did yesterday. Now the main thing you need to know of importance about this that might not be obvious is you actually have to find restrictions with the original denominators and then also find restrictions at the end result. Okay, so there's two really sets of restrictions that have to be found. Alright, so let's go ahead and just jump in. We're not going to do number 7, we're just going to do 5 and 6 to keep it simple. And then I'm going to take some problems off your homework. So first thing we're going to look at is this top fraction. Top of the fraction. So to keep everything consistent and easy to follow, I'm going to be color coding this. So I'm going to do everything in pink that goes with the top, and everything in blue goes with the bottom. Alright, just so you can understand what's happening. So first and foremost, looking at these two denominators in the pink, what is their numerical LCD?
6.
6. That's the smallest number that they both divide into. Okay, smallest number they both divide into. To find the the letter or variable portion, you want to take the higher exponent of that variable, which would be x squared. Now for in the blue, what is the numerical portion?
4.
And the variable is just x. Very good. So remember, that's our goal, to get that to have one fraction, each one become one fraction with that denominator. So we're going to have 1 over 6x squared plus 2 over 3x, and that's all going to be equal to something over x squared, 6x squared. So do I have to do anything with that first fraction? It already has the denominator I want. What am I going to have to multiply this top or the second fraction by? 2x. Because that's going to get me that denominator that I need, which is 6x squared. So this is just going to be the 1 plus, and then what is 2 times 2x?
4x.
Yep, 4x. So this whole thing right here is the numerator of my big fraction. Okay, now that we've made it into one fraction, combined it. Now we're going to do the denominator.
That was long.
So I rewrite my denominator fractions, and I know they have to end up with a denominator of 4x. With that being said, what would I have to multiply the top and the bottom of this fraction by?
2.
Good. So this fraction isn't going to need any extra work. So this is just going to become 2 times 1, which is 2, and then plus the 1, which is really just what? 3. So now we have to do, this is the numerator, and this is the denominator of that fraction. Now we're back to a problem from yesterday. Keep, change, flip. Okay? So we keep this fraction the way it is. We change the division sign to multiplication, and then we take that bottom fraction and we flip it. Everybody with me on how we got there? Now we can just multiply straight across. Now this can be reduced a little bit. Like I said, I'm really just hoping you can get to this stage today because it's a lot of information. But I am going to show you how I can reduce this. The x's can be reduced down to 1x here because you can cancel those out because it's multiplication. And then can't I divide both the 4 and the 18 by 2? Which gives me 2 times 1 plus 4x over 9x. That would technically be the most simplified form. Okay, but if you're still struggling with that, if you can get to this stage, that's good for today. What were my original restrictions on all my fractions here? 0. Did we come up with any additional restrictions throughout the problem? Yes or no?
I don't think so, no.
Alright, you ready to try another one? Okay. So as for the next problem, you're going to notice that the numerator, it doesn't have a denominator on that first part. So we're going to give it one by putting it over 1. I'm going to do everything color-coded so that you can follow along what's happening. So, as for the first one, what do you think the LCD is? The one in the pink.
X.
X. Good, because you don't have to worry about any numbers involved here, because it's just 1. And then the highest exponent on the x is just 1, so it's just x. What about in the blue?
X squared.
X squared. Good. Alright, so let's do the pink together. Our goal is to have x as our denominator. So the only fraction we really need to do work on is the first one. What is 1 times x?
X.
And it's just going to be plus 3. So that's our numerator. Now we're going to work on the denominator. And once you get the hang of this, you don't have to do each one of these steps separately and all that. So we know our denominator is going to be x squared. So the only fraction we have to affect is that second one by multiplying the top and bottom by x, which is going to give me 9 minus 3x. So now we can just do division. So we end up with x plus 3 over x times, remember keep, change, flip. This fraction is going to flip. Okay. And as it flips, I'm also going to factor a 3 out of this. So everybody see what I did there. I took this one and I just flipped it. And as I did that, I factored a 3 out of this right here. Okay. And this first one is just this. Okay, so the color coding may help. Now, before I make this into one big fraction, I can start cross-canceling a few things. I can cancel this x out with this x, but this one still keeps an x. Can I cancel out these two, the x plus 3 and the 3 minus x?
Yeah.
Even if we do the -1 thing, why can't we do it? Well, if I did the -1 thing, this would convert this into x minus 3, right? So that still wouldn't cancel with this, unfortunately. So my final answer is just x times x plus 3 over 3 times 3 minus x. Do we have any questions about that one? And then if you are wondering, the restrictions would have just been 0 and 3. Alright, so since it is my birthday weekend, I'm going to give you all a gift by allowing you to, not on your homework, you don't have to do number 8 and number 12.